welcome back. Today we're going to continue our series looking at design patterns. The pattern we're going to take a look at today is the Decorator Pattern, and this pattern is a structural pattern which allows you to extend or add capabilities to an object without changing its core behavior. This pattern provides a flexible alternative to use an inheritance model and can be especially useful in a scenario where you need to extend the capabilities or modify the capabilities of an object, but that object has been sealed, rendering it so you can't actually inherit directly off of it. So what we're going to want to do today is we're going to create a battle bot and have those battle bots fight in an arena. I've already created the arena. It is a pretty simple arena. It has a method called fight, takes in 2 battle bots, and it will return back the victor. And what will happen is essentially these 2 bots will swap taking jabs at each other until one of the bots has a life force that is less than 0. The battle bots all implement an interface, and they have a few capabilities. They have the ability to attack and defend themselves. They provide a name, a life force. The life force is how much life is left in that bot, and the life force taken per attack. So when they attack somebody, how much force do they take away from the other person? And here's my BattleBot class. It's pretty straightforward. It's sealed, as I was mentioning a minute ago. And when you construct everything, it sets the life force, sets the default life force taken per attack. And you'll see that because this is a private set, basically a read-only, I'm not allowed to modify this. So I'm going to want to do some tricks with our decorator pattern to basically create a BattleBot that can beat another BattleBot. So let's go ahead and bounce over to our unit test here. I've already created our bot arena. And let's go ahead and create an instance of a BattleBot. And we're going to say this BattleBot has a starting life force of 125. His name is Harvey. And we'll call him a normal bot. Now, we're going to want to create our new bot that will be basically our bot that will implement the decorator pattern. We want this bot to be an axe-wielding bot. So let's go ahead and do add new axe bot. And because I don't want to go and re-implement all the core functionality of the BattleBot, but I want to consume that BattleBot and modify that functionality or modify the intent of the functionality, what I'm going to actually do is have our axe-wielding BattleBot take an instance of a BattleBot at construction time. And we'll call this BattleBot our an axe-wielding bot. And then once we've constructed both of our bots, we'll have them fight. And the victor will be returned. Now clearly this will not compile or run at this point in time because, as you can see, I don't have an instance of the axe-wielding BattleBot. So let's go ahead and create that right now. So what we're going to want to do is bounce over our BattleBot class. And I'm just going to do all this in one place here just to make life a little simpler. And I'm going to create a new class. We'll call this axe-wielding BattleBot. We'll change this to public. And because I cannot inherit off of a BattleBot, you'll see it gives me a little squiggly and cannot inherit from a sealed class. All I can do is implement the interface. And when I do that, I need to implement some of the members. Let's go ahead and do that now. Now, I don't want to rewrite all the functionality of the BattleBot class because it does things I don't want to worry about. So how can we make it so we can consume it? Well, if you remember back to our unit test right here, I have our axe-wielding bot consume an instance of a BattleBot. So let's go ahead and create a constructor. Call this iBattleBot. We'll create an auto property off that, and we'll go ahead and mark that as private so that nobody else can see it. Now all we need to do is fulfill the functionality. Now to start with, I'm going to say that we're going to attack our opponent. Our bot is going to defend themselves from our opponent. We can return the bot.name. Life force, and then finally come down here and the life force per attack. Now at this point I haven't done anything spectacular. All I've done is basically wrapped our bot class and provided functionality. And at this point in time, if I didn't do anything and let them fight, the bot that had the highest starting life force would win. Well, we want to build a super cool battle bot. So what our battle bot's going to do, and it's going to be a little tricky, is it's going to say that every time it's on the attack, it's going to attack twice. And just for fun, what we're going to also do is say that every time it's on the defense, let's say every 10th time. So basically every 10th jab from its opponent, it can block it. And I can say if, I don't know, times attacked equal to 10, reset times attacked, else do that. So if it's the 10th time it's attacked, if it's the 10th time that it's attacked, it'll skip the actual attack. It actually won't use its defense. It'll just pretend it wasn't being attacked. Then it'll move on. So we've now taken an instance of a BattleBot and basically changed the functionality of this BattleBot. And what's great about this is here we're none the wiser within our arena because all we're doing is our interfaces. Looks like I didn't follow my naming convention correctly. Let's run through this and see what BattleBot wins. And here we go. So it looks like our axe-wielding BattleBot is the victor. And what was his life force at the very end was only at 42. So you know what? He only sustained about half damage, which is pretty good. Now what's cool about this pattern is I didn't actually change, for the most part, or couldn't change the underlying functionality of the BattleBot, but I sure could change the implementation functionality. And to the arena, all it knew about was the iBattleBot interface. So for all it knew, it was just two ordinary BattleBots fighting to the death. So you can see here how if you need to extend a class or modify the behavior of a class, but you either don't want to use the inheritance model because maybe you're already inheriting off of another concrete class, or you can't inherit off of it because you want to, it's sealed or something like that, well then you can use the decorator pattern to save yourself some time and to extend an object without too much effort. So I hope you learned something. Until next time.